Okay, guys, we are in 8.1, the search for origins. So we're in chapter 8. Here's what chapter 8 is about. It's about the formation of our solar system. Okay, so let's go forward. Now we spoke about four things that are, three things that are very unique about our solar system that could not have been coincidences, and the exceptions, okay? So, and when we come up with a theory of how our universe was created, what you need to look at is you need to look at the solar system. You need to say, okay, what is unique that there's no way this is by chance? And then create a theory that will answer those questions. So let's go through what those three things were that are very important. Okay, the first one is the pattern of the large bodies. Remember, they all orbit the sun in the same direction, and then almost everything rotates in the same direction, okay? Now, there are some exceptions. Remember, Venus rotates the opposite direction, clockwise. But that's the first question you got to ask yourself. How in the world is everything going counterclockwise? Like, there's no way that's a coincidence. Okay, so then number two, the next thing is the existence of two types of planets. There's no way it's a coincidence that there was 4 rocky planets, terrestrial, and then 4 Jovian planets, gas planets, just like that. I mean, if that's a coincidence, that's a crazy chance that we got all the terrestrials very close near the sun and all the Jovians very far away from the sun. There has to be some reason why they're separated the way that they are. Okay, number 3, the existence of so many smaller bodies. And what I mean is, why in the world is there so many asteroids and comets in our solar system? Like, they're everywhere. So there has to be some reason why all those things are there. Okay? And then number 4, if there's something that violates any of those things, what is the exception? Like, why is it that it's not following the rules that our theory that we're going to create about this, why is it that they are not following those rules? Okay? So, now the theory that we have right now is called the nebular theory. Okay, so first thing you need to know is, what is a nebula? Okay, you should know what a nebula is. It's a giant gassy cloud of just stardust out in the middle of nowhere. And I know you guys have seen them. Like, there's a bunch of nebulas here. Let's Google one real quick. Let's go with the horse. This is just one I know off the top of my head. The Horsehead Nebula. Okay, here's the Horsehead Nebula. It's just a giant cloud of a bunch of different molecules. It can be different things. It can be just different atoms. And these are pictures that we take of them. There's a bunch of them. There's the one I saw this morning was the God's Eye Nebula. Okay, there's the God's Eye, and there's a ton of them. I mean, if you look at them, you can find them everywhere. They're beautiful pictures. Remember, these are pictures, some of them taken in different types of light using the different telescopes that we have in space and the ones that we have here. And so remember, sometimes these are taken in different light, but a lot of times, like that one's a visual image. The reason why some of these look different is maybe this image is taken in X-ray and they've made it a false image, like we learned about in the last chapter. Oh, look, there's a one right there. Well, there was one right there that had the infrared and the ultraviolet way of looking at it, and then there's the visible light one. Okay, so there's a lot of these nebulas. You can check them out. They're beautiful. Beautiful things. Okay, I'm trying to get back to our PowerPoint. Here we go. Okay, so what the nebular theory states is that our solar system was formed by a giant nebula that gravity pulled it together. So it had a gravitational collapse, and it created a bunch of stars. So one nebula does is it creates multiple stars. And remember, we call it a nebular theory, not because we aren't sure if it's right, but we call things theories when there's a lot of things backing it up that this is true. The reason why it's still a theory is if we see something, some notable exception that maybe we need to change the theory a little bit so it fits that, we can, okay? It's not a law anymore because we're going to allow it to be changed a little bit if needed. But we know this is how solar systems are created, okay? So, where did the solar system come from? So it was a giant nebula. Different parts of the nebula, as you can see here. Okay, so this is a giant nebula. Different parts of the nebula gravitationally pull together, and they create stars in lots of parts of the nebula. So all the solar systems near us, or all the stars near us, would have came from that same nebula, which we call the solar nebula. Okay, and we called it the solar nebula because we call ours the solar system because of the sun, right? Okay, so this is called galactic recycling. So it starts out as a giant nebula. It collapses in a bunch of different areas, creating stars. Those stars create, generate nuclear fusion in their cores, create larger elements, and then they explode. And then that star exploding and many other stars exploding near it create another nebula. And then that nebula will then create other stars. And this is just a recycling program that happens, and it just creates more and more stars until they've created everything from hydrogen and helium into larger elements, or until that they've separated so far that they would no longer make any more nebula. Okay, so now how do we know this is true? I mean, we see this going on in lots of different parts of the universe. Now, we have never seen it actively happen through a full cycle, because a full cycle would take billions of years, okay? So, but what we can see is we can look out into the universe, or into our solar system, and we can see it happening in different areas. We can see one nebula creating stars. We can see a star dying. We can see a star that already died creating a nebula. And we can put all these together to get the idea of what a life cycle of a star looks like. Okay, so we have never actually seen it fall out the whole way, because we've only really been looking into the night sky for, so far that we can see stuff like this for a few hundred years, okay? So, and this cycle takes billions of years. So I don't know if the human species will ever see a star go through the whole cycle like that, because it takes so long. Okay? And that is everything for 8.1. I hope you enjoyed.